I'm going to put a bunch of trinomials up. I want you guys to watch the trinomials that I'm putting up and then tell your neighbor what the pattern is as soon as you figure it out. Okay, so here are all of the trinomials. Now, there is something special about these trinomials. And if you know what is so special about these trinomials, you can probably tell me what is supposed to go next. What's supposed to go next? What goes into that blank? A 16. Okay, so how do we get that 16? What are we doing? We're dividing the 8 by 2, and then you're squaring it. That's what you do with all these. You just divide the x term, the middle term, by 2, and then you square it. It works for every single one of these, even the negative ones. Yeah, yeah. What's that?
Are you recording this right now?
Maybe. Okay, so check this out. Look what else I can write. If I factor this, this would be x plus 5 squared. This would be x plus 3 squared. This next one would be x plus 6 squared. These are all called perfect square trinomials. You guys got that? Now, if I can write these perfect square trinomials as perfect squares like this, that gives me an advantage. It gives me a tool that I can use so that I can use square roots to solve any quadratic equation that I want. So for example, let's say you had something like this. Let's say you had x squared plus 8x plus 1 equals 0, and you wanted to use square roots to solve this. Okay, first of all, this is not factorable. I hope you guys can see that. Okay, and then you thought, okay, well, maybe I could solve this a different way. And so what you can do is you can move that 1 over to the other side and have a plus blank on this side instead. I moved the 1 to the other side. Now, if I move the 1 to the other side, it'd be a negative 1, but then I'd also have to have a plus blank over here. Whatever you do to one side, you have to do the other side of an equation. Whatever you do to one side, you have to do the other side. So what would I add to this side to make it a perfect square trinomial? A 16. We already did this, Mr. Patey. Oh, you're right. So I have 16 and 16. And then check out what I can do. Can I factor this? Is there another way I can write this? Yes, there is. I can write it as x plus 4 squared equals, and then this side I get 15 because negative 1 plus 16 is 15. All right, so how can I get the x alone now? Square root both sides. And so now I have x plus 4 equals plus or minus the square root of 15. And then I would minus 4 from both sides. I would get negative 4 plus or minus the square root of 15. And I cannot simplify 15. So those are my two answers. Negative 4 plus rad 15 and negative 4 minus rad 15. Those are my answers to this nasty dude right here. Now what I want to do is I want to graph this guy right here, this nasty looking dude, so you guys can see that this right here is the solution still. So check this out. You see the negative 4 plus rad 15? I plug that in, I get this number. Negative 4 minus rad 15, I get this number. And so what I'm going to do here is I'm going to go over to the y equals window, and I'm going to plug in the x squared plus 8x plus 1, and then graph it. Grab it. Look, there it is. Hey, what do you think? What do you think this x-intercept is right here? Yeah, let's see, it'd be 1, 2, 3, 4, 5, 6, 7. Negative 7 point something. Does that sound like our answer? Yeah. If I look over back here, negative 7.8729. So my x-intercept right here is that nasty number. What about this number right here? Yeah, my guess is that number right there is that x-intercept. And if we wanted to, we could use a function on the graphing calculator. We just press second and calc, then we hit 0, because the 0 is the same as x-intercept. And we could put this guy, let's go really fast. You put this guy over to the left side of the x-intercept. Where are you? There you are. So I'm going to put it right there, and then I put it to the right of the x-intercept, and then I say yes, guess, and then it gives me my exact x-intercept right there, which is actually the same answer that we have right here. So what we just did found the x-intercepts for this quadratic equation.